still ET time. And today we're going to talk about the data science pipeline. So basically, I think the data science pipeline within R can be separated into three groups: the data cleaning, data visualization, and model development. And it's not just like a direct path line from left to right, but it's like more like a loop or a cycle. You need to try several times to find the best model. So in this way, you need to do several types of data cleaning and try to visualize your data and try to filter out the outliers and find the best trend of your data, then got a decent model. So first, I'm going to talk about the data cleaning for at the start. So data cleaning is actually a very important part for the data analysis. Usually it can cost like 80% of the time of the whole data analysis. And it's quite useful because you can learn more insight of your data. And then you can trust of your data analysis results, for example, your model. With like the messy raw data, you may got some model results that may be not convinced or not correct. So data cleaning is actually to analyze, identify, and correct the messy raw data. And here, I think I list the four problems I think that's mostly common thing for the raw data. First, when you do the cleaning, you would like to remove the unwanted observations. And for example, the duplicated rows or the irrelevant observations. For example, if you have several data frames that combine for several times, and there's a probability that you have some duplicated rows that has exactly the same numbers. And those same numbers will cause some bias for a model, so you like to remove them first. And also for the irrelevant observations, because maybe you have a very big data frame and you only want to answer some questions that only relate to the parts of those data frames. So you can subtract those relevant observations for your model development. And the next problem is the structural errors, like the typos, the inconsistent capitalizations, and also you need to check for the mislabeled classes. In the right, you can see I made an example that I find from this website about the typos in the raw data. They actually count the different types of roof, like the texture of the people, like the domestic roofs. And you can see here I labeled with the red rectangular. The composition should like is the same with the capitalized composition, and you need to change those typos to make them at the same level. And also the inconsistent and also the mislabeled classes, because those mislabeled classes, in the R, the software gonna retrieve this at a different level in your model development. So that's gonna cause you some problems when you try to explain the models or try to understand the model results. Also, you need to check those different levels of your model. And another problem of the raw data is the outliers. But you need to remove those outliers very carefully, because those outliers may be in like maybe have some informations. And you cannot just like remove those numbers because you think they have like extreme values, because those extreme values may very informative to your model development and also for your data analysis. So when you do filter out the outliers, you need to really pay a lot of attention to your data and do not remove those values just because they have very abnormal values. And then another part is how to handle the missing data. I think is in our lab, because we have different data types, we call point in time or the time series data sets. So for the time series data, sometimes you can have these problems that you don't have the data in a specific time period. And there are two commonly used methods to deal with those missing data. For example, to just remove those missing data or to input those data with the mean value, which both of those two methods are quite have some hazard because you may drop some information from your model or from your data. So it's recommended to use some algorithm to estimate the optimal constant for those missing values and use those estimated values to input in your data frame in order to drop the information as least as possible. And when you do the data cleaning in RStudio, there is a package called dplyr that has been published in CRAN for a very long time and it's quite useful to do the data cleaning. And here I list the 5 main functions I think that's quite useful when you do data cleaning in R, including the filter, the selection, mutate, arrange, and summarize. And because RStudio is actually a software that's benefit for the human beings to do this, to write code and to write scripts. So you can guess those meanings by by those words. For example, the filters that represent you want to subset the data sets by a subset of rows in your data frame by specific conditions. And if you want to select some columns with specific conditions, you can use select. And here I would like to point out the mutate, which is quite useful when you try to do some basic data cleaning in your data frame. And the mutate, especially for the large data frame with thousands of observations, it's quite fast compared to the loop or the other functions. And also with mutate, you can combine with other functions that makes your data cleaning procedures more efficient and don't cost a lot of time. And I'm gonna show some demos when how to use those functions when I show the demos later. And after you clean all your data frame and you have several data frames that they contain the similar informations or they contain different properties of the same object, that you can combine those data frames in RStudio. And it's similar with the SQL database that we have the 4 types of join in the RStudio. And you can achieve those joins by the function such as merge and join. And for example, the inner join, which is to get the rows that's in both 2 data frames. And in the outer join, that is to get all the rows from those 2 data frames. And those functions are quite useful and are very similar to the SQL database. So if you're familiar with those, you can make your data cleaning procedures more fast. And when you finish the data cleaning and before you start to create a model, you like to visualize your data sets. And the data visualization is actually to present your data in a graphical formats, which enables people to gain more insight from your data sets more effectively. Because for the human beings, it's much easier for them to understand the graphs than just the numbers. And also with some with the effective data visualization process, you can identify some trends or the useful information from your data sets. And I think I also want to point out that when you do the visualization, not try to overload those informations within one picture, because it's going to be very difficult for your audience to understand all the information from just one plot. and you would like to make you would like to convey your informations from the data sets and the data plot to your audience efficiently and let them to understand more easily. So it's quite important to plot a decent way of your whole data set. And the data visualization in RStudio is also being developed for a very long time, and I recommend people to use ggplot2 to visualize your data. Because in my opinion, I think ggplot can plot the figures more prettier than the basic plot function in R. And also you can add different layers to your ggplot figures, which can make those figures contains different information and also easy to be understand. And I think the ggplot has been talked about in the first weeks of Tea Time by Alan. And if you would like to know more about the ggplot, you can go to the previous Tea Time and also Google it. I think Google is quite a good teacher for you to write your script and code. And when you think you have done the pre analysis and the pre deal with your data frame very well, you can start to develop the model. And I think in our lab we do regression models most. And in order to create a statistical model, I think you need to follow those 5 steps. The first is you need to separate your data frame into the training and the testing data sets and do the model, create your model with the training data sets. And also you can test if your model has overfitting or other problems within testing data sets. And after you separate those data into 2 parts, you can start to find the statistical significant variables for your model. I think it's also quite necessary when you do the modeling, because just assume you have a data set which contains the predictors, which is more than numbers of your observations. In this situation, you want to solve those equations, and you cannot get the estimate parameters for your model. So, and you also want to know which variables are quite important or significant to your responses. So you need to do the variable selection first and find those important variables for your model development. And with the selected variables, you can start to create the model. And based on the data visualization, you have a basic concept of the data trends. And you can try to use those mathematical equations to fit those data. And I think in our lab, we do several types of regression model, include the simple linear regression model, the nonlinear regression, the change points, and the spline models. And if you try different model and you would like to know which model is the best and can fit your data very well, you can use the model validation and the diagnostic plot to evaluate your model. For example, with model validation, you can use k-fold cross validation, and the more extremely condition, you can use the leave one out of cross validation, which is similar with the k-fold cross validation. Just you only leave one, you only use one observation as the testing, the validation test data sets. The diagnostic plots are also quite important and is a necessary part for your model development, which can tell you about your model residual or the model errors of your developed model, which can help you to also to identify the outliers and also help you to improve your model better. So I think those are the basic informations or the procedure that how you can develop the model. And I think for the remaining time, I'm gonna show some examples with RStudio to let people get more insight of how we develop the models here. I upload those this Armageddon and this PDF material into 18SDOT time. So if you like to have those materials and those informations, you can git pull of your repo and got the lately updated information from there. And those materials are in the week 4 data analysis pipeline folder, so you can find it there. So I think I'm gonna skip those prescription that is similar with our PDF I just showed, and then I'm going to directly go to the script. Can people see the screen clearly, or do I need to make them close? Okay. Okay, as I said previously, I'm going to use the dplyr to this package to do the data cleaning. And if you're not familiar with R, or if you're a new user of RStudio, you need to install this package and then library it. Then you can start to use it. So I already install and library those packages. So, and here I'm going to use a diamond data frame that's built in within the dplyr package, and I'm gonna name it as DPF as my demo. So let's take a look of our data frame. So because it's down, you can see this data frame is actually that's including the information of the price of different diamonds, including the different carats and the clarity and the color that's used to describe the quality of a diamond. And with dplyr, we can do different analysis or cleaning steps with our data frame. For example, I would like first to check if they have a duplicate observations in the data frame, and the duplicate function is a function that built in the dplyr package. And in with this, then we can see here. Sorry. We can see that shows if this row has duplicated observations. And because this data frame contains, you can see there, they have for 5,300 of observations, so it's quite a huge database, and I don't want to go them one by one. So here I can use which to let the software tell me which rows have those duplicate observations. I'm gonna run this script. You can see from here. This tells me that from those observations that they have the duplicated observations. And also, if you like to check those duplicate observations, you can also run this code. In this way, you can see here shows the example of those duplicated observations. You can see for all the columns, they have exactly same values, and which can cause bias for your model development, as I said previously. And then I would like to remove those duplicated rows. And here I put two methods that's how to remove the duplicated rows. The first one is the unique function. In this way, you can remove all those duplicate observations, and also you can use the duplicated function again and remove those duplicate rows. So just like this, and also parts as a DF database. You can see now if you remember, the original DF has more observations than the current database. You have problem? Question? Oh, because if you have those duplicated values, and that's can change, like can make your model, the adjusted square field model, a little bit higher because you have a lot of data points there. But actually, then this model may be not the correct one, but you don't know based on the high adjusted square. Okay. Yeah, I answered the question. I think if they if you have like duplicated observations, then they must have different like time points or other index. But here, those for all the columns, they have exactly same values, and there's no like no other index or column to separate them, to distinguish them. So that may cause problems for your model development. Okay. So, and with the deployer, we can also select the specific rows with filter function. And right now, I would like to select this diamond data frame with the cuts as ideal cuts. Then I can write the script like this and give it a new name called df select. And now you can see I got a new data frame that's the cuts, the column cuts here all have the ideal values here. And this is for the spec rows. And if you want to select the different columns, you can also use the select here. Besides using the select function in R, you can also use the sub or sub data frame that's also do the exactly same effect, just different functions. You can see here I got another data frame, and they only have those 5 columns that are specified in the script. And when you got this, and I want to add new variables. For example, I want to add a new variable called price per carat. That is the price divided by carats. And with mutate, you can just do it quite convenient and efficiently. And you don't need to run the whole loop to do one by one, so it's quite fast. And here you can see I got a new column or a variable that is called price per carat, and which those values are actually are the price divided by the carats. And with, as I said, with the mutate, you can also use other functions in R. For example, I use if else here. So I would like to create a new column called value, and this value, if the price of this diamond is lower than the median value of mean value of the price of original diamond price, then I call it low. Or if it's higher than this mean price, I'm gonna call it high. So I can run this script, and I can get a new variable called value, and that show me if this value of this diamond is low or high. And then we can use the head to just take a look of the first rows of our current data frame. And with arrange, if you would like to order this data frame by different order, you can use arrange function here. And right now I would like to them in a descending order. And I do like this. And if I take a look of the first row, the first several, again, you can see, then I change the price orders. Now it shows me the most expensive diamonds here, and they also have very high values there. So next one, I would like to aggregate my data frame to see average price, the price of my diamonds. You can see around $3,000 dollars, and you can see we do this. Oh, sorry. We do this for like several steps, and actually in R you can also use pipe, which is similar with the SQL database. You can use this as a pipe in R, and then this way you can do several steps just in one comment like this. I want to create a new data frame called ideal unchained diamond data frame, and I would like to filter out only the ideal cuts and only those columns, and they have this price per carat value. I can do this, then I got a new database that has exactly same information that I have done one step by step. And that is how we do data cleaning. And with those clean data, we can take a look of how the price changes with different carats. And because you already see that we have different levels of those diamonds, so I use color to represent the cost level here. And you can see, let me zoom in. With a ggplot, then you can visualize your data quite pretty. Here you can see I use different color represent different cuts, and for the ideal cut, which causes more the most procedures to get the high quality of diamond, which have the highest price among all types of diamonds. Because I think we talked about the ggplots before, so I'm gonna skip those data visualization part and go to our model development parts. So as I said, when you start to develop a model, you would like to separate the data into the training and testing data. And here I would like to introduce two different methods to do the data separation. The first is just like normally, I randomly choose 80% of the observations and use those 80% rows as the training data sets. And in this way, I create a sample size and browser train and the data set. Here they have ratio as 4 to 1 as ratio. And because we have different levels, and I would like to make sure that all those levels are in both training and testing data sets. So in this way, you can use a new package called carat and use the function called create data partition function. In this way, you can use you can separate the training and testing data sets by a categorical variable in your data frame. For example, I use a color here, and I do the similar thing and create the training and the testing data. In this way, I got a similar ratio in the observations for each data set, but in this way, I can confirm that all those levels are in both training and testing data sets, which are quite useful when you do data model development, and also the when you want to test your data with the testing data sets. And after I separate those data sets, I can start to try to select those significant variables. And again, I would like to introduce two different methods to do the variable selection. So in statistics, we have three methods to select the variables. We call forward, backward, and both variable selection. And the forward is that you start with a model that has no variables or the predictors in your model, and then you have the the upper model that include all those variables in your model. Example, I want to see the relationship between the price and the other variables for a diamond. So I create two models and use forward a model selection to find the statistical significant variables here. And it's gonna add one variable for each type and compare the AIC values. You would like to find the model with the lowest AIC. And in this way, we got a function that has all those variables in the model, which have the lowest AIC if you compare those AIC for different models. And also we can do a opposite way that we do the backward variable selection. And we can run again here. And you can see select the exactly same model as the forward variable selection. But actually those both forward and backwards variable selection has some disadvantages. Because when you add or decrease or remove one variable, this variable will not be added or removed again. So this can cause some problems, and we recommend people to use the both, like include the forward and the backward model selection. This way you can get the model more robust or convincing. And we can do a similar thing, and we got the similar results as the previous models or variable selection method. And another variable selection method to use a function or a package called OLSRR function, which are quite useful and robust. I think it also can give you some plot to see the variable selection procedure. For example, I use another data frame called empty cars in the cars package, and I would like to see it's actually shows the relationship of how miles per gallon versus house power. And in this way, I do exactly similar data separation, and I can do in this way. I only need to create one model and use this one model to do model variable selection with this function. And here I use a step both that's represent I do both including forward and backward variable selection, and I can do like this. And here's what I got from the variable selection. You can see it's more readable and contains more information of your variable selection. It's not only gives you what variable is used for your model, it also gives the statistical criteria of your models, including the R adjuster square, the RME ANOVA tasks, and also the parameter estimate for each variable. So basically, it's kind of combine the variable selection and model development. And as that, you can also plot this to see how it does the variable selection. So here you can see it can create me some different plots that shows the different statistical criteria changing with different variable added in the model. And if you specify which criteria you like to see, you can also do like this and plot again. Here I only want to see the AIC values. And then I got this plot. You can see for the fourth model, I got AIC value at this high, and with different variables in the model, I can decrease my AIC and I got the final model with the AM variables in the model. And that is the variable selection. And with those select model, I can start to select the variables. I can start to develop my model. So I show the different model types like linear regression model and the nonlinear. Here I use exponential model here because I see a nonlinear trend with the carat and diamond price, and also the quadratic term, and also the interaction term. When you do the interaction term or the quadratic terms in your model, you need to use those or multiply signal in your model so the R can recognize it and create the best model for you. And then with the summary, you can see the adjuster square, the estimate parameters for the current model. And so here, I think for the model with interaction term, I can got a nice adjuster square, and you can see for those variables, they also have very high significance that can be shown by theirs the high statistical significances here. And after I got this, I would like to test those models to see if they have overfitting, and I can use the testing data set, and I would like to calculate RMSE from the testing data set. Actually, there is a RMSE function in R, so you can directly use this without writing the equation for yourself. And we can see for the most simple linear regression model, I got the RMSE as 1,100, which is quite high. And if I change, then we can also do evaluate for which have a lower RMSE, which also represents maybe I don't need to worry about the overfitting of my model developed. And with plot function, you can see the diagnostic plot of your models. So here you can see we have the residual plots, which is better to show there's no trend along the fitted values. Also the basic normal QQ plots, and the ideal QQ plot should be a line like laying down on this diagonal lines. But here you can see we have some shifted around the two ends. That represents we have some the residue is not normal distributed, and we need to remove our model, maybe do some power transform or other data transformations to try to improve those models. And also we can see with a different data set, we do exactly similar thing. And here, because I would like to try to validate my model, then I use a k-fold cross validation here, and I use k as 10 or as 20%. That represents I use 80% as the training and use another 20% as the testing data. And here I show example that I wrote a loop function that to run this 10 types of k-fold cross validations, and then I can see results here. So here I try to get the RMSE for different models, including the linear model, the change point model, and the test and the spline model. Maybe it's a little bit small here. But generally, it's used to see if you have overfitting and how, and also it can be used to evaluate your develop models. And with the mean function, I can see the RMC for different models. For example, for the linear regression model, I got RMC at 2.88. And if we got a more complex model, for example, the cubic spline model, then I got a different but lower RMC here, which represents this can explain more variance of the data set, and maybe can be choose as the best model for your data set. And also after I decide which this one I can use this one is my best model, then I can plot it again to see how the residual and the errors of my model. And now you can see for the residuals with the fixed values, which shows no patterns here. And with the normal QQ plot, you can see those actually laying down on this diagonal line. So we don't need to worry about the residual, like normal distributed residuals. And those plots also show this model can successfully explain the variance of this data set, which represents a nice development model. And that's the basic pipeline for us to try to develop a regression model. And I think today's topic may be helpful for you to start or trying to improve your model development skills. And also we like to improve, like have more improvements and try to find another more different methods to get our coding and the script more efficient and fast. Thank you for coming to today's tea time, and hope you learned something from today's topic. And that's all.